Riley finds a new bank that will earn her 14% interest compounded daily. Create a new function if Riley puts $200 in that account as well and find out how much she would earn in 2 years. So in this case, we're using compound interest and it's compounding more than once a year. So in this case here, it's daily. So this end value is changing to 365. My principal stays at 200 because that's how much she's putting in, and my rate stays at 0.14 because it's still at 14%. The only thing that changes here is the end value. So what I get for my function here is principal of 200 times 1 plus 0.14 over 365, which is going to be a tiny number, and then 365 times t. So really quickly, 0.14 divided by 365 is a small number. And again, if you round this, you got to be careful because the more that you round it, the farther away your answer is going to be from the final answer. So what this ends up getting, and I'm going to write it all out for you just to show you what I got, is 1.0003836, and this is still probably rounded here, but basically I'm writing all of this out when I added 1 plus that decimal there to the power of 365t. Now, that's my equation, and again, this number is unwieldy, not fun to deal with, but what we can do from here is now if I'm saying, hey, after 2 years, what I'm going to do is 200 times 1.0003836 to the power of 365 times 2, which is just 730. So now I'm going to take this number and I'm going to put it to the power of 730. Now, once it does that, it's going to give me a number again, lots of decimals, 1.3230587, blah, 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 forever. And what we're doing from here is multiplying it by 200. Again, if you round that number and then multiply, you might get a little bit different of an answer. But once I multiply that after 2 years, we find that Riley will have a total of $264.61. And I'm rounding to the nearest cent here. So be careful with the rounding. Otherwise, you should get 264 and 61 cents.